Beth, I just walked through the living room where my kids are doing online school, and boy, does it look different this year.
It sure does, but those teachers are doing some amazing work.
I can only imagine the things that they've seen and heard.
Let's head over to one of those digital classrooms.
Miss Beckham, do you know how long the claws are on a grizzly bear?
I don't know, but if you're at risk of being attacked by a bear, you punch it in the nose. Or wait, is that a shark?
I ate a shark once on vacation. It just tasted like any other fish. I wonder what Mimo would taste like.
Online school and working remotely can be fun and sometimes a bit frustrating.
I can't wait until things get back to normal. No one really works like this.
Actually, there are some jobs that are all remote, and some are really remote. Think of the folks that are working on the latest mission to Mars, the Perseverance rover.
They actually had to put it together and then launch it. All that had to be done in person.
The folks who built and tested the Perseverance rover, they were in person, but they're never going to physically see it again. It's never coming back from Mars.
Yeah, but they can communicate with it. They'll be in touch.
Every communication will take up to a half-hour round trip.
Slowest text messages ever.
And if you thought it was frustrating waiting for things to be shipped from online shopping, imagine having to wait 10 years or more for the sample return mission to bring you some Mars rocks.
Wow, that's amazing that they're able to do all of that remotely.
It must take a lot of hard work.
It does, but like the name of the rover, they will persevere.
And this is 7:30.
It may take a half hour to get a message through to these guys.
Hi, I'm Marty.
And I'm Beth. And normally we are coming to you from the Smithsonian Institution's National Air and Space Museum, either in downtown Washington, D.C. or in Chantilly, Virginia.
But today we're at our homes. And as you can see, working from home has its challenges.
The folks that work on robotic missions to Mars have been doing this for a long time, to the point that some of the people, one of whom you'll meet later, wore a watch set to Mars time.
Today we're going to look at the challenges and successes of working remotely on the Red Planet. We're also going to look at the Perseverance rover.
To get us started today, our friends who you met earlier will be joining one of our colleagues, Shannon, and they'll be taking a closer look at the Mars rovers.
Hey everybody, I'm really excited to be with you today. We're going to take a look at some pictures together. Are you all ready for that? And have we ever sent anything to Mars from the United States? Thumbs up or thumbs down? All right, cool. I'm glad I got some thumbs up there. We've landed robots on Mars, right? What are some of the things that robots do on Mars? Somebody can raise their hand or unmute and let me know. Austin, what are some of the things robots do on Mars?
I'm pretty sure they collect like rock samples.
Absolutely. Angelo, what do you got?
Yeah, I think they collect rock samples too, and also secretly search for water on there.
I don't know if it's so secret actually, but yeah, absolutely. They collect samples and things too. Mackenzie, what do you have?
Maybe they look into the ground to find sites of life there.
Yeah, that's an awesome idea. Emily, give me one more and then we're gonna take a look at that photo.
I believe they take pictures so we can see what Mars looks like.
Yeah, that's a really awesome one. And I love that you said pictures because now we're gonna look at a picture together. I didn't pay her to be here, folks. Can you tell me something that you noticed in the picture?
I noticed that rovers can be in different sizes.
There's definitely a size difference in those rovers, right? Can anybody tell me why you think the sizes of the rovers might be different?
It might be different rovers are for different purposes.
I love that. I love that you talked about different purposes. What else is in that photo that might help you figure out how big something is?
The person next to it.
Yeah, it's really helpful for me to know how big they are because there's a person in there. So let's go back to talking just a little bit about the purpose of these rovers. How can you tell by looking at these what they do?
Well, I think the medium one is mostly for taking pictures because it has that like really long pole and it kind of has almost looks like a camera attached to the top.
Mackenzie, what do you think?
I noticed that the middle one kind of looks like it has wings. I don't know what that'd be used for though.
Those actually are solar panels. Anybody tell me what a solar panel does?
I believe they collect energy for your house or something.
What do you think the solar panels on the Rovers might help it do?
To help them move around and like basically like a battery.
Yeah, exactly right. Curiosity doesn't have any solar panels on it, so we're gonna look a little bit closer at it. So it's really tough to tell, but Curiosity is actually nuclear powered, and nuclear power lets us work for a really long time. So Curiosity's batteries can run for a really long time up there. So you see Sojourner has a solar panel, and Spirit and Opportunity had solar panels. Why do you think we switched when we switched to Curiosity, Austin?
Probably because if you had solar panels, it would take a lot longer for it to get like fully charged up because it's a lot bigger than the other ones.
That's a really awesome point. It's a much bigger rover than those other two rovers. Mars is covered in dust, that like red, dusty, powdery stuff. It's iron oxide, which is what makes it red. And sometimes that dust can blow around and it covers up the solar panels. So even if it's a really bright day and the sun is shining and there's dust all over those solar panels, they don't work that well. So the first two rovers were studying the rocks. They were trying to figure out what the rocks were made out of, maybe if there was water on Mars at some point. And then Curiosity is a biologist. What Curiosity was looking for was potential signs of life, or at the very least, things that could have supported life. They were looking for things like water and evidence of other elements that might be on Mars that meant that a long time ago that Mars could have potentially been a place that hosted life. You all were really awesome and helped me answer some questions about these rovers.
Jaden Jefferson is a student reporter from Ohio who has covered everything from the local news to presidential elections.
And Alex Mather chose the name for the Mars rover, Perseverance.
Let's head over to Jaden and Alex.
Please join me in a big round of applause for your classmate who submitted Perseverance. Alex Mather, come to the stage.
I'm Jaden Jefferson, and I'm joined by Alex to talk about his role in the new Mars rover project. Alex, thanks for joining me.
Thank you. My pleasure.
So you had the opportunity to name the rover. What did you name it? And what do you hope people years from now take out of this experience that you're having?
I named the Mars rover Perseverance, and I hope that people in the future will look at this rover as a shining example of human perseverance for years to come.
And how were you chosen to name the rover? What was the process in order to be chosen by NASA to name it?
Space enthusiasts around the world narrowed it down to 155 people, and these people were the semifinalists. And eventually, they narrowed it down to the final 9. They narrowed the 9 down into 3 names, and eventually these 3 names got to Dr. Z, who is the director of science at NASA.
There has never been exploration, never been making history without perseverance. Perseverance and curiosity together are what exploration is all about.
What were some of the thoughts you had went through in order to get to Perseverance?
I did research on the missions and what they did. I did research on what this mission was going to do. One day, I just realized that Mars missions are so hard, and there's incredible perseverance shown by both the mission and the rover itself. So why not just go with that one?
Curiosity, insight, spirit, opportunity. If you think about it, all of these names of past Mars rovers are qualities we possess as humans. But if rovers are to be the qualities of us as a race, we missed the most important thing: perseverance.
And you want to make a difference, and you want to work for it, you can get that thing. If you put in the work, you can make a positive difference in the world.
Alex, thanks for joining me.
Thank you.
We are joined by Dr. John Grant and Dr. Mariah Baker, who are both planetary geologists and have worked on multiple Mars missions.
Thank you both for joining us today. John, we're learning about the Mars 2020 mission. Can you tell us about the search for life on Mars?
One of the important parts of looking for life on Mars is knowing where to go and what to look for. And the Mars program that's been put together is really geared towards doing just that. The missions that have led up to Perseverance have identified a landing site where we think we know where to go, and we've got the tools on board to look for the things we need to look for. And specifically, we're looking for biosignatures, the kinds of signatures that relate to evidence of past life.
John, there's also a pretty cool part of this mission, but it's going to take a little bit of time to pay off. Can you tell us about the sample return?
Sample return is really the gift that keeps giving. When we take a rover or a spacecraft to Mars, we can only bring a certain number of instruments with us, never as many as we'd like to have. And by bringing samples back to the Earth, that gives us a repository, sort of a legacy, that not only allows us to take those samples and parse them out through all kinds of different instruments, but it also allows us to keep some for 10, 50, 100 years down the road when new instruments are developed that allow us to extract new information from those samples.
Mariah, can you tell us how this mission will help us prepare to send humans to Mars?
Yeah, absolutely. Although the primary mission goal is to search for these ancient signs of life, one of the secondary goals is to prepare for future human exploration. So a large part of this, and something that I study myself, is understanding the environment. So things like wind, understanding dust activity, which we've seen has been a hazard before. We're also going to look into using this atmosphere to our benefit and using it as a resource. So the MOXIE instrument is going to try to intake carbon dioxide from the atmosphere and turn it into oxygen that can be used by astronauts. So the mission is really going to help us take a step forward towards making human exploration a reality.
Mariah, we've gone from Sojourner, which landed back in the 90s, through Spirit and Opportunity, Curiosity, and now Perseverance. Are these all totally separate missions, or are they connected?
Yeah, so every mission that we send to Mars has its own primary science goals, and the spacecraft design and mission architecture are based around those goals. But that being said, we have a long legacy of past missions, and so we often use the knowledge that we've gained from these past missions and the technology that we've tested before as a basis for guiding and designing these future missions. So for Mars 2020, for example, the basic design of the rover is based on the Curiosity rover design, but we've updated and upgraded the payload with new and upgraded instruments to specifically address the science goals of the mission.
John, a lot of us have been doing teleworking and distance learning, but driving rovers on Mars takes distance learning to a whole new level. Can you tell us a little bit about that?
Some of us have actually been doing remote operations for a while, but now the entire operations team is doing that. And really what that means is all of your tools that you depend on to get the job done really have to function the way you hope they do. And I will say that every day when we have to do operations, I tend to start the day with a little bit of sweaty palms, hoping that all of those tools will work, because Mars doesn't care. We really have to be ready for what the rover is going to do and when it's going to do it.
The Mars 2020 mission didn't just start at liftoff. It started way before.
When Curiosity landed on Mars in 2012, work began on the next Mars rover mission. Though Perseverance looks similar to Curiosity, it's a big step forward in technology and in our goals for Mars exploration. First, there was a lot to learn from Curiosity, both from its scientific mission and from how the rover performed on the surface. The engineers at JPL noted that Curiosity's wheels were sustaining damage from sharp rocks, so they got to work designing new wheels for Perseverance. And as Curiosity returned data to Earth, it provided information that helped shape the mission goals of Mars 2020. From here, JPL scientists and engineers designed the technologies they wanted to have on Perseverance, technologies to look closely at rock samples and to stash the most interesting ones, to look underground, to test the air, and to see every part of the environment around the rover. They built and tested these technologies, Sherlock, RimFacts, Meta, and they integrated them into Perseverance. On July 30th, the Mars 2020 mission was ready to go.
And liftoff.
the spacecraft lifted off the pad at Cape Canaveral, Florida, and began its nearly 7-month journey to the Red Planet. The Atlas V rocket lifted the payload into space and separated, completing the launch part of the mission. Now it was on its way, the cruise phase. The launch date was not picked randomly. Every 26 months, there is an optimal window when the trip to Mars is the most efficient. What we see here is the transfer orbit, a planned path between two moving objects, Earth and Mars. The spacecraft is traveling at about 50,000 miles per hour, or over 80,000 kilometers per hour. Because we know the exact distance, trajectory, and speed, we already know that we will land on Mars on February 18th. As we get closer to Mars, the cruise phase ends and the approach phase begins. On February 18th, we will begin entry, descent, and landing. Every part of this is autonomous. No human is controlling the landing. First, we jettison the cruise stage, which we brought all the way to Mars but don't need anymore. Now our craft looks more like the capsules that return to Earth. And even though the atmosphere is thinner on Mars, entry is still hot and dangerous. The capsule has to turn to an entry attitude, turning the heat shield to enter the atmosphere safely. Once we're inside the atmosphere, the goal is to slow down, which isn't easy in a thin atmosphere. Automated programming prepares for the jettison of the heat shield. Then the parachute is deployed. This slows things down a lot more. The heat shield is released. The surface of Mars is approaching quickly. Then the back shell and parachute is jettisoned, and retro rockets fire. Our descent has now slowed to a manageable speed. The camera searches for the correct place to touch down. Once ready, the sky crane activates, lowering the rover to the ground. Once sensors indicate that the rover is safely on the surface, the descent stage separates and does a flyaway, crash landing far away from the rover. And here we are on Mars.
John, we had to choose a specific place on Mars to land. Can you tell us where we're going to land and how we chose that spot?
The science community really came up with about 30 different candidate landing sites. And we focused in on and selected the Jezero crater landing site because it's a place where there used to be a lake. And as important as that, there's also on the western side of the crater a place where a river flowed into that lake and deposited a large delta. And it's those sediments in the delta and in that ancient lake that in parts are underneath that delta that really focus our attention on where to go look for biosignatures and possible evidence of past life.
Okay, John, the big question is, are we going to find life this time on Mars?
The Perseverance mission, really, the landing site selection, the instruments on the rover, have all been selected to try to answer that question once and for all. We don't want an answer that we don't have confidence in. So we really kind of picked a place on Mars where we think that if there's evidence of past life, it ought to be preserved there. And so by going to Jezero crater, we really hope that we're going to have a yes or no answer about whether or not there was ever life on Mars. We won't be left scratching our heads and wondering.
But you're telling me that we probably won't find any little green men?
No little green men. We would have seen evidence about that long ago.
While the rovers on Mars are going to be looking for life, we want you to try this at home.
When looking for life on other planets, scientists are not necessarily looking for life form itself. Looking for clues about creatures on Earth may include looking for footprints and nests. While scientists don't expect to find footprints on Mars, they may find trace evidence of life, like carbon dioxide or other gases. When baking bread, we used yeast as a common ingredient. Yeast is a single-celled microorganism that feeds on sugars and starches. When yeast eats, it releases carbon dioxide gas. Today, we're doing an experiment to detect the CO2 that our yeast is creating as it eats sugar. You can follow along and try this at home if you'd like. First, put the yeast and sugar in the bottle. different amounts of sugar should produce different amounts of CO2 gas. The more sugar you feed your yeast, the more gas it will release. In this experiment, we tried 4 amounts of sugar in our bottles. My bottle had no sugar. It's our control. Mackenzie only added 1 teaspoon of sugar to her bottle. Angelo added 2 teaspoons of sugar, and Emily added the most by feeding her yeast 3 teaspoons of sugar. Add the warm water to the bottle and give it a few swirls until the yeast and sugar have dissolved. Stretch your balloon over the mouth of the bottle. Now wait.
You all did a great job, and we can see your detection devices there. Mariah, how does this relate to looking for life on Mars? Are there little Martian bread factories we're looking for?
Living organisms often exhibit a set of characteristics that help us identify that they're actually alive. Now, these include needing nutrients and energy to survive, but also that living organisms often release or produce chemicals, or what we call biosignatures. And so in this experiment, the yeast was the living organism, and when it was exposed to the correct environment and nutrients with the sugar and the water, it was able to produce CO2 as a biosignature and fill up those balloons. So even if you didn't know what was actually in each of your bottles, you might be able to infer which one had the living organism and the correct environment just based on how big the balloon had blown up. So what we do on Mars is pretty similar. We are often looking for evidence of these biosignatures in the rocks and in the atmosphere that may have been produced by life in the past.
Can the rover detect only certain things? What if unknown things come up?
Yes, so the instruments that we send on rovers and landers help determine what measurements we're going to be able to take. So unfortunately, there are only certain things that we can do, and we do our best to send a good payload with a diverse set of instruments that can get a lot of different kinds of data. But as I mentioned, this will be the beginning of Mars sample return, which will allow us to use even more instruments back here on Earth and determine even more from the samples that we're collecting.
You all did a great job with your science demo, and Mariah, thanks so much for joining us today.
Thanks for having me, and thanks to the scientists for performing these experiments.
We've talked a lot about the science that's being done on Mars, but it will take a pretty incredible rover to get it done. It's been worked on for years and has been designed using the lessons learned from previous missions. Here's a quick rover view of Percy, the Mars rover Perseverance. To help us, we have Katie Stack Morgan and Matt Golombek, both from NASA's Jet Propulsion Laboratory.
Hi, my name is Katie Stack Morgan, and I'm the Deputy Project Scientist of the Mars 2020 Perseverance rover. I'm a JPL scientist working on NASA's next flagship mission to Mars. Perseverance is the first mission in a potential Mars sample return campaign whose purpose is to bring samples from Mars back to Earth. Many of the science instruments on the rover contain spectrometers, which means they measure things like light, radiation, mass, and composition. First, we'll start with the mast or head of the rover. On the mast of the rover, we have 2 science instruments, SuperCam and MassCam-Z. SuperCam is one of the spectrometers I talked about, and this spectrometer shoots a laser at the surface of Mars, creating a plasma that's analyzed by the spectrometer in the SuperCam instrument. And that's how we tell what the surface is made of. We also have a set of cameras on the head of the rover called MassCam-Z, and these cameras can zoom in and out and basically serve as the eyes of the rover. On the neck of the rover, just below the mast, are a series of sensors that act as the weather station for the Perseverance rover. Some of the most exciting science instruments on the Perseverance rover are located on the rover's arm. The 2 instruments on the arm of the rover are Pixel and Sherlock, which also contains a camera called Watson. Pixel is an X-ray spectrometer that will identify what chemical elements are present on the surface of Mars. It looks at a very small area, about the size of a postage stamp. The other instrument, Sherlock, is also a spectrometer that uses a laser to identify minerals, organic molecules, and potential signs of ancient life. We'll use these 2 instruments, Pixel and Sherlock, together with the fine detail provided by the Watson camera to search for signs of ancient life and look for those biosignatures on the surface of Mars. There are two other science instruments on the Perseverance rover located on the body of the rover. RIMFAX is located in the back of the rover in its underbelly and uses radar to study what's underground. We can't use cameras to see what's underneath the rover, so we use RIMFAX to understand what the structure of rocks is underneath the rover. Lastly, we have MOXIE, which is an instrument that prepares for future human exploration of Mars. MOXIE is able to take carbon dioxide from the Martian atmosphere and convert it to oxygen. This oxygen can be used to support human life on the surface of Mars, as well as create rocket fuel that can get those astronauts living and working on Mars safely back to Earth. But wait, there's more! In addition to this amazing roving laboratory that we're sending to Mars, it also brings along with it a flying machine. My colleague Matt is going to tell you all more about that.
Hi, everybody. I'm Dr. Matt Golombek. I'm a planetary geologist at the Jet Propulsion Laboratory in Pasadena, California. And the mission I'll be talking about is the Ingenuity helicopter. The helicopter carries two counter-rotating blades, a solar panel, communications antenna that sends data back to the rover, a small electronics box, and 4 landing legs. The helicopter is carried on the belly pan of the rover. After landing, the rover will drive to a location where the helicopter will be deployed, probably fly at altitudes of about 5 meters. We will traverse anywhere from a few meters initially in our initial flights to maybe 50 or more meters away and back. It carries 2 cameras, a black and white navigation camera that is looking pretty much straight down, and that's used for tracking the location of the helicopter during its flight. And the second is a color camera looking off to the side. The one looking off to the side should be able to image our rover. That'll be about 100 meters away, and it will see everything from the horizon to things that are up close. So you can think of this as a scout that could go out and view terrain and decide the best places for the rover to go. And that is the Ingenuity Mars helicopter.
So that's our tour of the Perseverance rover. If you'd like to learn more about the rover, visit nasa.gov.
A wise man once said, "Time is a river, but Perseverance is a rover."
And we are just about out of time. But before we go, we want to share with you some great resources about Mars and Perseverance.
STEM in 30 has produced a lot of videos on Mars, and we've created a Mars playlist on YouTube. There you will find a whole bunch of videos about Mars, including interviews with experts, animations, and astronauts telling about future journeys to Mars.
Our friends at the Smithsonian Channel have also created a couple of amazing resources. The first is Making Tracks on Mars, the Smithsonian Channel's mission critical special that goes into detail about the entire Mars 2020 mission.
Drawing on the resources and research that went into this special, they have created Mars AR, an augmented reality experience. This thing is cool. Interact with Percy and its rover predecessors, and even drive the rover and fly the new Mars helicopter.
We are out of time, but we want to remind you that no matter what your situation, there's still plenty to explore.
We've never filmed an episode of STEM in 30 all remotely before, but it was kind of cool. Online learning and work is definitely different, and there are some challenges, but there are some great opportunities to continue your learning journey.
And speaking of journeys, what do you hope we discover on Mars this time around? Let us know in the comments section.
And if you like this video, be sure to follow STEM in 30 on Facebook and Twitter, and subscribe to the National Air and Space Museum's YouTube channel.
Thanks for watching.
Bye. 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 Bye, everybody. Bye.
Bye, Marty. Bye, everybody.
Bye, Paul. Bye, John. Bye, Ryan. Bye, Dan. Bye. Bye, everybody.
Bye. Bye. It's taking forever. Bye. Bye.